Hello, everyone. Thank you for joining us for our Valencia Water Reclamation Plant virtual tour. I am your host, Genesis Rodriguez, a public affairs specialist with the Los Angeles County Sanitation Districts. We have two speakers here today, but before we get into the presentation, I just wanted to go over a few things. If you have any technical difficulties, please feel free to put them in the chat. But if you have any questions, please put all your questions in the Q&A section. At the bottom of your screen, there's a Q&A icon. This will help us be able to sort through your questions and get them answered quicker. So for troubleshooting, the chat feature, and then Q&A for any questions that you have. One other thing, this tour will be recorded and it will be put on YouTube. So if you go to youtube.com and you type in Los Angeles County Sanitation Districts, you'll be able to find this recording by Monday of next week. So without further ado, oh, you guys can also use the raise your hand feature. So if you would like to ask your question yourself, you can definitely use the raise your hand feature and we'll get that going. So without further ado, let's introduce our speakers for the day. We have Basil Hewitt, our public information supervisor, and then we have the real star of the show. Sorry, Basil. We have Mary Lee, our operations engineer. So take it away, Basil.
All right, I'll be quick so we can get to the star. Thank you, Genesis. Thank you, Mary.
Wait. I'm sorry. One last thing.
We got to get to the star.
I'm sorry. One last thing. Please stick around after because I will have a poll. We're always looking for feedback. So we'll do a quick poll before you leave at the end of the presentation. So thank you. Take it away, Basil.
All right. Thank you, Genesis. Thank you, folks, for showing up this lovely Saturday morning. And we're trying to create the effect of the tour we would have had if it weren't for COVID. We would have walked around the lovely Valencia plant. So if you have questions as we go along, please bring them up, and Genesis will break in the way she's really good at and ask Mary or I the question. So with that, let's get going. Let's go to the districts that formed in 1923. So let's have a slide here from 1923. This is an actual image of raw sewage going into Santa Monica Bay. So you can imagine the havoc that created in terms of the environment and public health. Typical life expectancy in LA County in the 1920s or early 1920s was about 55 years of age. So folks got together and they wrote a law called the Sanitation Districts Act, and we were formed in 1923. So from those humble beginnings in the South Bay, we now have grown to be to serve 24 sanitation districts that you see here. We serve about 5.6 million people. As far north as District 14, you see on this map, that represents Lancaster and Palmdale, and as far south as Long Beach. Today, we're going to focus on this SCV, you see on this map, that represents Santa Clarita Valley Sanitation District. And one of the neat things about our agency is that even though we serve 5.6 million people, each of our sanitation districts based on drainage area, and it also it results in local control. So the board of directors for the Santa Clarita Valley Sanitation District are 2 members from Santa Clarita City Council and 1 representative from the LA County Board of Supervisors, because the boundaries of that district are basically the city of Santa Clarita and unincorporated LA County. We now have 11 wastewater treatment plants that do the heavy lifting of treating your wastewater. These 11 wastewater treatment plants you see here represented by the pins on the map. They treat about 400 million gallons of sewage a day. That's enough sewage to fill the Rose Bowl 4 or 5 times a day. And if you think back pre-sanitation district, that sewage, we're always going to generate sewage. It was going into our rivers and ocean. Now we clean that up. We clean it up into recycled water. Today, we're going to focus in on 2 of our our sewage treatment in Santa Clarita Valley. On this map, you see the Valencia and Saugus treatment plants, and I have a close-up shot of that particular district. The dots here represent the Saugus and Valencia plant. The shaded area is the service area, the area that the sewage drains to these two treatment plants. The Saugus plant can treat about 6.5 million gallons per day, and the Valencia plant that Mary's going to talk more about could treat up to 21 million gallons per day. Now we go to, and today we're going to focus on the Valencia plant. And with that, I think I'm going to turn it over to Mary. Mary, you're muted.
Hi, everybody. My name is Mary, and I'm the operations engineer for Valencia Water Reclamation Plant. Welcome to the virtual tour today. Before we go into details of treatment process, let's talk about what is wastewater. So here's a clip showing when you flush your toilet or take shower, brush your teeth in the morning, or doing laundry, they all require water. Each person creates about 85 gallons of wastewater a day, and the water you use, it goes down to a drain, to a pipe below your house, and we call these sewers. The sewer system is quite amazing. It's a huge collection system underground that runs for miles. And I'm sure most of you guys have seen manholes on the street. And underneath those manholes, right here, underneath those manholes are actually sewer pipes. These sewers are built sloping down towards the treatment plant. So your wastewater arrives at the treatment plant with the help of gravity. And gravity really is our friend for wastewater treatment because it's free. So we don't have to use pump or additional energy to move wastewater from your home to the treatment plant. Wastewater treatment plant, I'm sure you guys already know, but it's a place where wastewater is treated to a very high level of quality and can be safely reused. And as Basil mentioned earlier, reusing water is especially important in Southern California, where weather is dry and we often experience water shortage. The Valencia Water Reclamation Plant processes wastewater and all the solids generated in the sewer. This treatment plant was first constructed in 1967 with an initial capacity of 1.5 million gallons a day. And since then, we have a couple expansions, and now the treatment capacity is at 21.6 million gallons. 21.6 million, it's a little bit hard to grasp for some people, but imagine a gallon of milk that you see at grocery store, and you just multiply that by 21.6 million gallons, and that's how much the plant can process. So that's a lot of flow. And most of the plant process have been upgraded throughout the last 20, 30 years to meet more stringent discharge requirements. And we have our upcoming project includes ultraviolet facilities and advanced water treatment facilities, where Basil will cover a little more in the later slides. Typically, if we have tours on site, this is our starting point. But the difference with the virtual tour is that you don't get to have the delicious coffee and donuts that we usually provide for our attendees. So hopefully you have your own coffee and while you're listening to this virtual tour. Okay, so the first stop of this virtual tour is our control room. And I call this is the brain of our treatment plant. The operators can pretty much control the entire plant remotely. They can see instantly on their screen how much flow is coming in, how much flow is going out, the status of our equipment, the quality of our effluent. And we can operate pumps, we can turn it on and off, open or close valves, and just by click of their mouse. And if anything is out of ordinary, we have alarms that are sent to this control room to alert our operators of potential issues in the field. Now let's go through the process of treating your wastewater. There are really three main mechanisms to clean wastewater. And those three mechanisms are physical, biological, and chemical. As we go through the treatment process, you will see one of the three or a combination of the three mechanisms being used to clean your wastewater. Now, the first major step is called the primary treatment, where we're removing large visible solids in the wastewater. And the very first thing that we do when the wastewater enters our plant is to use mechanical screening equipment to remove large objects like wipes, rags, and plastic bags. And one of the interesting things that I've heard at one of our treatment plant is that operators sometimes see dollar bills or diamond rings in the bin. So if you ever accidentally lose your diamond rings, now you know where to look for them. So here's a close up of our bar screen, and we call these flex rake bar screens. And we have 2 bar screens working on our site. Here's a good video, pretty cool video that shows you how the screening equipment works. So we have these rakes that moves vertically to catch as much debris and solids in the raw sewage, and we convey the solids upward. The solids then goes into grinder and a compactor before it's dropped into a bin or a trash bag nearby. So this video shows what comes out of the screening equipment. The debris that gets picked up by the bar screens, it's a little bit different from plant to plant, but what we've seen consistently throughout all of our WRPs is that we see these flushable wipes. The flushable wipes, they don't dissolve in water like toilet papers do, like the video that you just saw. So they do end up in our wastewater treatment plant, and it actually can do more serious damage to our pumping equipment. And those repairs can actually be quite costly for us. So as part of this tour, we really want to urge people to refrain from flushing those seemingly flushable wipes down the toilet. It may be convenient, but it actually creates a cost burden for your wastewater treatment plant. From here, I kind of just want to stop and see if there's any questions so far. Genesis?
No, you're good.
Okay. So after the screening equipment, wastewater enters our influent pump station where wastewater is pumped from about 30 feet below grade to the surface. Here's a photo of 3 of our 6 influent pumps. And one cool thing about these virtual tools is that we can actually show you photos of places that we typically don't take our tour groups to. And from the influent pump station, the wastewater is pumped into our grit chambers. Inside these grit chambers, we are removing grits, eggshells, sand, and smaller particles to protect our downstream pumping equipment. And we can prevent grit settling in our pipelines and channels. We have 4 grit chambers, and each of them is about 6 feet deep. From the grit chambers, wastewater flows by gravity into our primary sedimentation tanks. So here's a photo of our primary tanks. At this process, where the main point of this process is to remove oil and grease that floats on top of the tank and remove more solids at the bottom. We do add chemicals such as polymer and ferric sulfate to enhance our settling. And as you can see, these tanks are typically covered because we do want to be good neighbors, and we're actually really close to Magic Mountain, so we wouldn't want those riders to smell anything foul when they're screaming their lungs out up there. So let's take a closer look of the floatable materials when we open up one of the lids. So you can see a little bit of grease and still a little bit of sand up there. And this is the inside of a typical primary sedimentation tank. Wastewater spends about 2 hours in our primary tank, and we have a total of 14 primary tanks, about 65 feet long, about 11 feet deep. This clip shows you how the flight and chain works to skim off materials on top and push materials that settle down at the bottom. Just from this treatment, we're removing about 60% of the impurities in water. The wastes that are collected into the hopper, we call this primary sludge, and they're pumped to our digester for treatment. And I will talk about a little more about digesters in later slides. Now, this is a photo of our gallery underneath the tanks. Just like sewer system, we also have piping underground to transport wastewater and sludge from one location to another within the plant. Do we have questions, Genesis?
No, you're good.
Okay. After the primary treatment process, the flow actually gets diverted to our equalization basin, and I'll refer to that as an EQ basin, just in short. And flow are diverted when we have high flows, which is typically in the morning when everyone is waking up to brush their teeth and getting ready for work. The flow from EQ basin gets returned to the plant later during the day and night when we have lower flow coming in into the plant. These basins are actually pretty important for us because it balances out the loading to our treatment plant. So we don't have to make drastic adjustment to our mechanical or chemical equipment. So now that we're done with primary treatment, which is mainly using physical mechanism to take large solids out of our wastewater, now we're gonna move on to secondary and talk more about the biological process to treat our wastewater. And this is what our aeration tanks look like. There's a short video.
And there's Six Flags.
And there's that's Magic Mountain, Six Flags in the background. Yeah. We do hear screaming sometimes when it was operating. I see a Q&A. Should I stop, Genesis?
Yeah, so the question you just got, it's from Ken. He asked, how much solid waste is generated every day in terms of tons / garbage truck fulls, etc.?
We get about 100 tons a day. Actually, I have that number. Hold on, I'll get back to you when we talk about the solids. But we generate about 100 tons of solids per day, and so it's 25 tons per truck, so 45 trucks a day and 20 trucks per week. Anything else?
Yeah, that's it. Okay.
So at this stage, we're using microorganisms to do all the work for us. For the microorganisms to survive, it needs food and oxygen. So it uses the organic matter in wastewater as the food source. And with the right amount of oxygen, the microorganisms are able to convert ammonia into a nitrogen gas. Our atmosphere is composed of 78% nitrogen. So if we release more nitrogen, it's actually not harmful to our environment at all. This plant has a total of 12 aeration tanks. And there are trillions of microorganisms, or MOs, in our aeration tank. These microorganisms spend about 5 hours eating the organic matter in the wastewater. Each treatment plant has its own lab that takes sample of our mixed liquor on daily basis just to make sure that our microorganisms are in healthy state. Mixed liquor is a term that we use to describe mixture of microorganisms and the primary effluent in our aeration tank. And from the aeration tank, mixed liquor enters another settling tank. And again, right here, we're allowing the gravity to do the work for us to settle out solids in the mixed liquor. Solids that are settled at the bottom of the clarifiers are now called sludge. Some sludge are returned to aeration tanks to achieve the appropriate food to microorganism ratio, and some of them are wasted. And this is a photo showing you the inside of what our secondary clarifier looks like. And you're right, it looks a lot like our primary, and it uses the same mechanism. We have chain and flight that pushes heavy stuff at the bottom to the hopper, and we skim off anything that's floating on top. The treated water then flows out of these teeth-looking weirs. We call them weirs. Wastewater spends about 3 hours in our secondary clarifiers. And now, by now, you should be able to see a quite drastic change in the quality of water. And we're only halfway through and about 10 hours into our treatment process. Previously, I mentioned that we have to waste sludge from our secondary clarifiers. But you may wonder where are those sludge going? And so let's take a detour from here to talk a little bit about solid handling. Before those waste sludge from the clarifier goes into our digester, it's thickened using these tanks are called dissolved air flotation tanks. Basically, the technology here is that we use small air bubble to separate solids from water and force all the solids to the top, and we skim the top layer off, and we pump those to our digesters for further treatment. This is a photo of our digesters. If you're there on site, these tanks are actually about 20 feet above ground and about 10 feet below. The purpose of these digesters is to kill off pathogens and decrease volume of our sludge and to get rid of odor. And what goes into these digesters are what I mentioned. It's our waste sludge from the clarifiers, and as well as our primary sludge. And the primary sludge are the stuff that settle out at the bottom of our primary tanks. And these are called anaerobic digesters because we're not introducing oxygen to these digesters. These digesters are kept at 98 degrees Fahrenheit, pretty steady, in order to allow the right amount, the right bacteria to survive and to break down the sludge for us. And thanks to these helpful bacteria, again, we're actually producing methane as part of the breaking down process. We use methane gas to fuel our boilers, which supply steam to our digesters to keep the digesters at the 98-degree temperature. So this is a very cost-effective operation.
Hi, Mary.
It appears we have a little bit of technical difficulty, and we will get Mary back on the line. Give us 1 minute. I think we lost the internet connection.
Did you want to pull up?
Yes. Do you have the slides? Do you have the slides as well, Genesis?
Yeah.
All right, let's pull up. Sorry about that. We can't wait to get back in person. We've lost the star show, so we're the fill until the star gets. Yes. So bear with us in less than a minute.
At first, I thought it was me.
I thought it was me as well.
Okay.
We don't want to lose our audience.
Yes. Sorry. Let me
share your screen, and when Mary gets back on, we'll have her take over. So.
Okay, perfect. And so we were on the last slide is primary.
And I'm so glad you're here, Genesis. Now I see
you.
your function.
So our last slide was primary?
All engineering systems, yes, let's go to primary. All engineered systems have to have redundancy, and this is our redundancy in this.
Okay, so, oh, great, thank you. Someone, last slide was digesters. So, we'll
Share
go
your
back.
screen.
Yeah, I'll just
We're
share my
losing
screen.
them. They want to go back to sleep. All right. Goes through primary. So we've gone through. Wastewater goes through primary treatment. Next slide. And we've seen this. This is my favorite slide. And now we're in second. We saw the biological processes. As Mary said, now we're in the digesters, and you get an idea how big these digesters are. Here's a board inside. Oh, Mary is back. You want to let her in?
Yeah. Oh,
Yeah.
she's already.
Oh, I don't. Okay.
Oh, there you go. We got Mary back.
Yeah. And this gives you how big the digesters are. Most of the digesters above ground, or most of the digesters below ground, but this board gives you an idea how big the inside of a typical digester are. I know, Mary, you didn't want to do this. You didn't have to get bad Wi-Fi on us. All right, go ahead. We're back at the digester.
Oh, okay. So let's see. So these back we're at I think I dropped out around when we're using methane gas to fuel our boiler,
Yes.
which applies steam to our digester to keep the digester at a constant temperature of 98 degrees. And that's a very cost-effective operation because the digester is constantly reusing energy that it produces to continue the treatment process. Each digester is about 750,000 gallons, and the sludge spends about an average of 30 days inside these digesters before they're sent to our dewatering process. And this is this is what the inside of a typical digester look like. Those columns that you see coming down, they're used to provide steams and gas to the system. And I think Basil was pointed out that there are wooden planks against the wall, and those wooden planks are about 6 feet. So that kind of gives you a perspective of how tall how deep these digesters are. Okay. This is a photo showing inside of our dewatering building. This is one of the 2 filter press units we use to squeeze water out of the digested sludge. We dewater the sludge from 3% to 20% at this point. And this is a cool video showing our filter press operation, which is a series of plates that sandwich the sludge in the middle, and that's how we squeeze the water out. The dewatered sludge is now referred to as cake or biosolids. And as the plates open, typically the cake will just fall down to the hopper by gravity, but sometimes the cake sticks to those cloths. So that's where you see our operator using scrapers to make sure all the cake is removed from the cloth. From the hopper, the biosolids is sent to another tank waiting to get picked up by our hauling trucks. Here's a cool video showing our truck loading process. So the truck comes to the building with a scale at the bottom, and it loads up to 250,000 wet pound, which is about 25 dry tons per truck. So here it's right at 25,000. About 20 trucks come through our plant per week to pick up the biosolids. And these biosolids are used at landfill. And we're using these for landfilling purposes. Any questions? I see 2 Q&As. Genesis?
Yeah, did you want to go through any that were relevant
Yes.
since I'm sharing screen?
What questions?
Mary, could you read them?
Oh, does the main thing produced create the total energy use or other power source needed to power the boilers? We have enough methane to power to work our boilers, and we actually flare extras to the environment. So we have 3 flares on site, and we flare methane that are not used. The next question is not related to water reclamation treatment, but is there a virtual solid waste tour? Basil?
Yes, we have a virtual solid waste tour as well. You can visit our YouTube page, the district's YouTube page, and see the virtual solid waste tour we did earlier in the year.
Are biosolids considered toxic and biohazards? Do they eventually get buried? No, our biosolids are actually grade B. And so we, directly from the truck, we have contract with Holloway landfill, and that they actually take our biosolids and they use it in their landfill to fill up holes. Are any of the solid sludge composted for fertilizers? It used to, but the existing contractor, we're not doing that. But we have, I guess for other facilities, we do use them for fertilizers. Okay.
And there was one other question about what does it smell like when you walk through secondary treatment?
Secondary treatment, it doesn't smell bad at all. I mean, I think most of the smell comes from primary, so that's why our primary tanks are covered for that reason. Secondary, it's not bad. I mean, Basil, what do you think it smells like?
I'm so used to it that I enjoy walking through that.
Yeah.
The primary is where you get a lot of odors and they're covered. And secondary treatment at that point, I'm so used to it, I don't even notice it. During secondary treatment, primary is where I really notice it. So I enjoy when we do the tours. I enjoy opening the lid and seeing the reaction of folks, both to the visual and the smell. But we have it covered and it has a slight vacuum. But secondary treatment, I don't notice it, or I don't even know how to describe it. You're probably you can describe that better.
For me, it doesn't. Yeah, I can't. If I come up with a good analogy, I would. But for me, it doesn't smell bad at all. Okay, so Genesis, can we go back to? So I'm going to continue on. Now we've covered the secondary treatment and solids handling. We're going to continue on with our wastewater treatment process. And the last stage of the process is called tertiary treatment. The treated water out of our secondary clarifiers now enters the dual media pressure filter. And think of this like the Brita or pure water filter you have at your house. The water trickles through the media from the top and is purified that way. But for our pressure media filters, the water enters through the top and it goes through anthracite, sand, and gravel. And with this process, the remaining suspended solid in wastewater gets attached to those media and gets cleaned that way. Next. At Valencia, we have 14 pressure filters. We call these pressure filters because they're enclosed and water is pumped into each filter and creates pressure inside. Pressure filter takes less space than our typical gravity filter, but they also require more cleaning and backwashing. The very last step of the treatment process is to disinfect our wastewater. This is where we kill off bacteria, pathogens, and virus in wastewater by using ammonia and sodium hypochlorite. If you guys remember the 3 main treatment mechanisms, physical, biological, and chemical, so this stage is definitely very chemical heavy. The sodium hypochlorite are the tanks in the center of the photo. Water spends about 2 hours in these chlorine contact tanks, and the chlorine residual at the end of these contact tanks are extremely crucial. So we have analyzers throughout our tertiary treatment to make sure that these water are chlorinated properly. So after the chlorine contact tanks, we still have chlorine in our effluent. So having chlorine in water is not safe for our natural habitat. So before we discharge treated water to river, we actually add sodium bisulfite to dechlorinate our our treated water. And these 3 tanks here are the sodium bisulfite tanks. So from the moment that your wastewater reaches our plant, it only takes 12 hours to convert your wastewater to a water that can be reused and discharged to a river. Now let's take a virtual tour down to the river discharge. We have a pretty nice trail at the west end of our treatment plant that takes us to the river discharge location. So this water definitely looks very different from the sewage that first came into our plant. This water is safe for recreational use and is safe for fish and other natural habitat that lives around the area. About 13 to 15 million gallons of water comes into our plant, and most of the flow comes here to for discharge and for reuse. And a little bit less than 1 million gallons a day is reused for golf courses and green belt irrigation. We're constantly upgrading and improving our treatment plant process in order to meet more stringent water quality requirements. Now, Basil is going to talk about our current construction at Valencia and why those projects are extremely important for us.
All right, thank you, Mary. So the water that goes into the river, our water is great quality, is tertiary effluent produced after 12 hours, but it has the regional board, the agency that regulates our discharges, has said that our chloride concentration is too high for the uses of that water along the river. Right now, our chloride concentration in our effluent is about 120 milligrams per liter. So we have a couple of projects that are underway, well underway, that will bring our chloride concentration to 100 milligrams per liter or less to meet the regional board's requirements. Genesis, can I get the next slide? We're currently constructing UV disinfection facilities, both at Valencia and at Saugus. And you say, well, how does this UV disinfection facility bring your chloride concentration down? Well, as Mary mentioned, we disinfect using bleach, chlorine. And so when you disinfect with that, that adds a certain amount of salt or chloride in the water discharge to the river. By cutting back on the use of bleach and using these ultraviolet light bulbs in these canister tanks, the water, the secondary effluent will go through there and it'll deactivate viruses and it'll disinfect the water without having to use as much chlorine or bleach. And what happens there is that we'll reduce our chloride concentration. So these 2 projects at Saugus and Valencia are well underway. We were a little bit delayed because of litigation that slowed up construction, and COVID slowed us up, but they should be completed by 2021, by the middle or end of next year. Next slide, please. But the big deal is this advanced water treatment facility. You're looking at an aerial of it. You see the area that, as you go to the north, pause it 1 second, Genesis, if you could do that. So if you could point out the UV disinfection facility for me, because I don't have cursor control. You'll see the UV disinfection facility where Genesis' mouse is at. And as you go further north, you'll see the advanced wastewater treatment facility. And basically what this is going to do, there's a number of facilities. You have a microfiltration that'll occur there, nanofiltration, and then what we call reverse osmosis. And this facility is not going to take all the flow from the Valencia plant. It'll take a fraction of the flow, as much as 8 million gallons a day, and it will create ultra pure water with a very, very low chloride concentration, and we'll blend that with the remaining water produced by the plant and then discharge to the river to meet the 100 milligrams per liter target. And that project should be done in 2022. As you can see, there's a lot of work going on there, and given these COVID times, there's been some adjustments, some delays, but the contractors are proceeding ahead with the proper safety precaution. And both of these upgrades to our facility should be online in the UV next year, advanced treatment 2022. And that's it. It's a story of the Valencia treatment plant and how it's, as Mary said, it's always grown. It's always protected public health and the environment. And we're always adjusting to meet the needs of our community. With that, we'll take, hopefully all the questions are for Mary. We'll take more questions. And Mary, you can turn your camera on. You can't run and hide. I have a couple of questions. Mary, are you there?
I got
Mary?
him.
Yeah, I'm trying.
Okay, so one of your questions, and I think unless Genesis, you want to read the question, because you can now.
Which
I could say, Mary talked about how you became an engineer, or the pathway one takes to become an engineer at the sanitation district. And then what do you like about your job?
And that's from John Dahl. Thanks, John.
I just read the questions. I
don't. Pathway, I actually started internship with the district on the second or third year of when I was in college. So that kind of opened up to my career path with the district. I was already under civil and environmental, but underneath civil and environmental, it's a huge umbrella. So it was kind of hard to pick exactly which emphasis I want to go into. But with the internship, it opened up to, I was able to visualize wastewater. I enjoy working with the district. When I was interning, I learned a lot from it, and it really helped with my school as well. So, when you're doing school, when you're doing problems, you just see squares and on papers. You don't know exactly what tanks look like. You don't know how wastewater comes in and out. So internship really, really helped. I started in design section, which was a good transition from school to work, because I was able to apply a lot of equations to work. And after 8 years in design, and I transferred to my current section, which is the operations section, and I enjoy quite a bit, just because there's a lot more people interaction, and you see more of a daily issues that we encounter. So there's a little bit more day-to-day troubleshooting, which I really enjoy.
Okay, so now this other question is from Ken, and while we're on the same topic, Mary already kind of answered this. Now, Basil, can you tell us what kind of training or education is required for your position?
It's just, I'm a civil engineer, just like Mary. Studied civil engineering, did a master, and so on. So it's very similar to Mary's. I guess the other question is, what kind of training would you need to be an operator, or in the control room?
That one, I don't have a lot of information on that.
So you can go to, there's a number of tests that you can study for, and a number of the community colleges offer programs in wastewater training and become a wastewater operator, and people take classes and pass a number of certification tests.
I know LA Trade Tech and Rio Hondo is very famous for that. So closer to Valencia, I'm not sure, but there are community colleges that offer wastewater specific courses to help you get certified. All right, so next question is from Dave and Peg. Are all prescription drugs that are excreted by people removed from wastewater? How?
Do you want me to try and take that one, Mary?
Sure.
I guess that's a complicated answer. So one of the things we like to have, we want to make sure prescription drugs aren't flushed down the toilet or put down the drain. So one of the things we've been doing since the late 80s is sponsoring free household hazardous waste roundup, where you should bring your prescription drugs there. And we have it once or twice a year, I guess, in Valencia. Genesis is free of charge, and your prescription drugs can be brought there. In terms of medication that may be excreted, the treatment process removes a lot of those medication, and we don't, at this point, we don't see any negative effects, but we're studying the full implications of excreted medications on the aquatic population and so on. And just the primary secondary process removes a lot of the medications you might have in there, and microorganisms will consume some of them.
And let me just plug in our beloved HHW program, our Household Hazardous Waste and Electronic Waste program. There are roundups that happen throughout LA County, including areas in Valencia throughout the year. And so this is a free and convenient way for residents to dispose of their household hazardous and electronic waste. So for more information, I will be typing the link down in the chat. All right, so our next question is from Rebecca. Could you explain more the advanced water treatment methods of ultra purification?
You want me to do that, Mary, or you want to do it?
I can give it a shot. So the advanced water treatment facility is actually quite complicated, but in general, so we take our filter effluent from out of our pressure filter that I mentioned earlier, from those pressure cylindrical looking ones. The effluent from there, it goes through our microfiltration, and microfiltration are the ones that looks like I think they look like spaghetti. They're just little tiny spaghetti tubes that the water goes through and then filter out that way. And then it goes to our nanofiltration, which is more of a membrane type. And from the nanofiltration, it goes to our reverse osmosis. It looks a lot like nanofiltration, but it's got a tinier pore in the membrane. And the main thing of microfiltration and nano is really they're like a pre-treatment for RO because of how small the pores are in our RO membrane, it gets clogged up very, very easily. So MF and NF are really just to get more solids, and solids meaning suspended and as well as dissolved solids in water before we go to reverse osmosis. And the whole purpose of the reverse osmosis, like Basil pointed out earlier, is really to remove our ultimate target, which is a chloride.
Yeah, and I guess if I could just simplify, just think of each of those steps from microfiltration to nano to reverse. You're going smaller and smaller pore size. If you had a sieve and the holes were getting smaller and smaller, that's what's happening. So those first two steps, we took out compounds that were bigger in diameter. But as we get to reverse osmosis, you're getting much smaller. And to get that, and we need energy, we're almost forcing the water through that reverse osmosis filter and keep the impurities on one side and have pure water goes through. So you're going from bigger pore sizes to smaller, and you varying amounts of energy to force the water through, if that helps. And then the stuff that's left over, we have the clean water, and then we have the brine that we dispose of, or are we going to dispose of by trucking it to our main plant in Carson.
All right, so our next question, which I like, we have noticed what we call a large, quote, water slide off the 5 freeway. Is this part of the plant? And if so, what does it do? Do you guys know? There's like a big, when you're driving on the freeway, there's like a lot of water coming out of like a hill and it's just being dispersed.
No, that's not us.
What is that?
I don't know. I don't know if there's a dam there that they're releasing water, because they release it once a while. Oh, someone says it's the aqueduct.
Oh, okay, that's what it. Okay.
It is a good question because it's in the area.
Yeah.
So I used to wonder that when I was little too. All right.
So
So
there's one question on fire suppression. We actually do use our chlorinated water in for our fire water system at the plant. So we do use some of the treated water for our plant use.
okay, so the next question is from Doug. Outside of the ick factor, could the water technically be used for drinking?
The law doesn't allow you to drink the water, but it essentially meets drinking water standards because the yuck or ick factor. You know, when we give the tour, I always tell people the water that we produce from this treatment plant is cleaner than the water 2 billion people drink every day. But in this country, in this nation, we've decided that we're not going to drink it. Once it goes through the advanced purification facility, then all bets you could, the law would allow you to drink it with some modification.
Next question. Do you have a lost and found for those diamond rings that go down the drain?
I don't think so. I don't even know people because once you flush, I mean, it could get stuck in the sewer pipe for a while. It could get stuck at the just a various location in your sewer system. So from the point that you flush your valuables down your drain, it's kind of hard to say when it will actually arrive at the treatment plant. So no one ever looks there.
Okay, next question from Ken. What are your thoughts on COVID testing and water levels? Or is COVID too widespread in our community at this level to have any value?
I know our labs, they do take they're monitoring, but I don't think there is a conclusive.
So our lab at our San Jose Creek treatment plant and our plant in Carson developed testing to test for fragments of the coronavirus, and they've been doing that since this whole pandemic started, and to great result. If you go to lacsd.org, you will see on our headline pages the latest laboratory results. And by counting up the fragments of the virus in wastewater that comes into our two largest plants, you can get ahead. It's usually a leading indicator by about 10 days or 2 weeks what you're going to see in terms of infection or hospitalization. So if you go to our website, you can see what our lab has been able to do. And we've been working with public health officials sharing that information. And hopefully it becomes another tool to let us know when we have the virus under control, when we have the situation under control.
And I just put the link to the latest report
Yeah, it's pretty
in the chat.
fascinating.
It's really cool. And by the way, let me just say I appreciate our audience very much. They're a wealth of information. Tammy says that water slide is water from the Owens Valley that is in the big pipe that runs through Saugus. It is stored in the reservoir across from the slide. So,
Oh, cool.
FYI.
Did not know that.
I'll point it out to you next time. So, all right. So next question. What type of materials are used to create the nanofilter?
Well,
I have to look at the type of. I'll have to get back to you on that, on the actual material.
yeah, I'm not sure. We could get back to you.
Yeah.
Sure.
So next question. Why can't the sludge turn into water instead of dropped off for fertilizer?
Do you want me to handle that, or you?
Sure.
So what you're dealing with when the sludge is first removed from primary and secondary, it's about 97% water and 3% solid. And so what Mary showed you that with the presses, what we're trying to do is like a sponge, squeeze out as much water as possible. So it goes from like 97% water to about 70% water and 30% solid. And that allows us to have a lot less trucks to go off site. And the only thing I would say is that what percentage of our body is water? I forget that, to give you perspective. So it's, we've removed a lot of the water from it. And I think, so there's always going to be some some water in it. And we've removed a lot of the water. So we have a lot less trucks leaving the site.
It's up to like 60%.
So our body's
like
60% water. So we're in that
like 60
range.
to 70.
If you look at this, the biosolids as it leaves the Valencia plant, it's about 70% water at that point.
20% in the biosolids.
When it leaves the plant, so it's 80% water at that point.
Yeah.
80% water at that point. So.
All right. So next question is this is related to the fire question. For the fire, I was thinking of fire trucks and the large water tankers that fly overhead and drop water on fires. Could we use your water instead of potable water to fill the trucks?
Fire department, they're requiring those water to be potable. So they typically don't like to use our disinfected water directly.
Okay. Our next question, it looks like our last two. What efforts are underway in Sacramento to approve direct potable reuse of water? And will the advanced output from your facility eventually be available for drinking water purposes, assuming that legislation is passed to allow that use?
I'm not sure where I know it's something that a lot of people are working towards, and something, at our other treatment plants, we think it's something, the day should come where if we clean up the water enough, we can put it back into our potable water supply, and we would work with like water purveyors. I think, what was the other part in terms of the Valencia plant? At this point, I'm not aware of any plans like that. Most of the water goes to the river, and this less than 500,000 gallons per day is used at the golf course and the green belts from the treatment plant to the golf course. So in terms of, we think it's a great idea for California in general. We support it, and hopefully it occurs at some of our other treatment plants. But at the Valencia plant, I'm not aware of any analysis or any work done to utilize the water that way.
Yeah, and there's another fire department related question that just came in. Would the fire department be able to use the water from the new advanced water treatment facility?
I would think they could, but we can't, because those RO treated water is quite important for us too, because we're blending those water with our normal river discharge. The whole purpose of the advanced water treatment plant is to lower our final chloride level to 100. So the method that we're taking is we're blending really, really clean water with way less chloride with a portion of river discharge that still has chloride in there. So we need to blend the flows together.
Perfect. And our next question, where can we view today's recording? So you can view it on YouTube. If you go to youtube.com, type in Los Angeles County Sanitation Districts, you'll see our little logo there, and we will have it up by Monday. And so I think next question is, I understand the goal is to get to 100.
Will the plant go lower? I think it'll be pretty difficult because the water that comes into our plant, and we're talking about water from Basil, is it from Delta?
Pardon? So the effluent, the wastewater that comes into our plant is about
125, 130.
Yeah, it's about 125 milligrams per liter. The potable water may have 65 milligrams per liter of chloride. When we use it, we add another 45 to it, and then when we disinfect using chlorine, we may add another 10. But as I mentioned earlier, as we go to UV disinfection, we'll knock out about 7 milligrams per liter, and then the advanced purification facility will create such clean water that when we blend it, we'll get under the 100 milligrams per liter target that the regional board, the Los Angeles Regional Board, would like us to meet. Hopefully that wasn't too many numbers.
So next question is, can you take on rainwater and sewer water together?
So
Together,
right,
I mean, when we receive our wastewater, rainwater when there's rain event, it actually infiltrates through the manhole, and from the manhole it gets into our sewer. So when there's rain, it's a mixture of rainwater and wastewater in our sewer that comes into our plant.
but our sewer system, especially in Southern California, is not in cities like New York or places where it rains quite frequently. Stormwater or rainwater is mixed with sewers typically. It's not cost effective here to combine storm runoff with sewage, because if the rain event occurs once in a while, you would basically waste a lot of money making your pipes or your sewer pipes or conveyance system much bigger than it's needed on a typical basis. But we are working with throughout, I mentioned we have 24 sanitation districts. And if there's a particular area where we have extra capacity in our sewer system, we're willing to work with the local jurisdiction and get stormwater and take stormwater into our system, the initial, I don't know, half an inch, quarter inch, and put that through our treatment plant and clean it up. So on a case-by-case basis throughout the sanitation district, we're looking to see how we can help clean up stormwater throughout LA County, because that's a big environmental issue as well.
Okay, perfect. So please, I'm launching a poll. If you could please give us your feedback, rank today's presentation from 1 to 10. 1 being awful, 10 being Basil likes to say metaphysical perfection. I'm okay with awesome. So just rank and don't worry about our feelings. And then for additional feedback, please email us at info@lacsd.org. So let me put that in the chat as well.
And we can't wait to get back out there and walk around the treatment plant on a Saturday morning in the fall.
And while you guys fill out the poll, we have another question from Mark. Are you ready to take on more communities in Santa Clarita?
I'm not sure what, I don't understand the question.
I'm assuming it's like if we have the capacity for more sewage, like if Santa Clarita expanded.
Oh, so the way that works, we have a particular drainage area, and if you're within the boundaries of the sanitation districts, and let's say you're on septic tank, you would just have to connect to the sewer system, and we could take more sewage. So we're sized for the drainage area. If people want to add to or annex to the sanitation district, there's a process for that too, where you can connect, reach out to us. We'll look at your home or your development, and we'll tell you if there's enough capacity in the sewer system. And then after getting the appropriate approval, then we can add you to the sanitation districts. Because we have treatment capacity at this point, right? The Valencia plant, what did you say the design capacity was again?
It's a 21.6, and we've noticed that because of water conservation, that a lot of people are doing such a great job with. So I'm sure we'll have to talk to facilities planning, but I'm sure the forecast for that design capacity can probably last a little bit longer than what they had anticipated before.
Yeah, because the per capita wastewater generation rate is going down. A number of years ago, it was like 100 gallons per day was what the typical person generated in terms of wastewater. Mary mentioned 85, and it may be even going down. It may be already closer to 60 or 70 as people go and, buy equipment or utilize washing machines that require less water than old stuff.
All right, cool. Well, thank you. It looks like that was our last question. Please fill out the poll if you haven't done so already. And again, any feedback you have, please send us an email. We love finding new ways to make these virtual tours even better. So with that, I think that's it. Thank you for sticking with us through our technical difficulties, and we hope to see you on the next one.
All right, thank you.
Thank you.